Our botnet console is designed to help security teams stay ahead of advancing botnets with API and application protection that evolves with changing behavior. In this case, we're going to be investigating a botnet that's attempting to stuff various username and password combinations to try to gain unauthorized access. Focusing on this brute force credential stuffing botnet, there's a few specific attributes that we can start to track about its behavior. The first attribute that we can focus on is this botnet's risk score, and it represents how malicious of activity is being generated from all of the member bots being tracked. Next, we have threat type. This could be a threat actor, but in this case, we're recognizing that this is a botnet. Also, we recognize the intensity is low for this botnet. Next to that, we have the max level. And the max level represents really the type of behavior being identified from this botnet. And we can see here that there are some exploitation behaviors being identified. The botnet definition helps security teams consolidate and analyze the various types of behaviors that are being tracked and considered as credential stuffing. Next, we're going to dive into each one of these specific behaviors so that you can understand how the ThreatX platform is detecting various types of credential stuffing activity. First, let's dive into this specific rule identifying 3 unique login attempts from a single IP, all within 1 minute. It's easy to say that this behavior is brute force. Now, because of the type of activity of using login credentials so aggressively, we can start to say that this is a key indicator of credential stuffing. Now, the quantity of match events is what can help us understand really the magnitude of different member bots' behavior. But there's other different types of behaviors that we can expect from credential stuffing outside of attempting to actually log in. Other types of behavior could be similar to business logic abuse, as this example of detecting a weak password being submitted within a login form. Now, this is an active exploitation that we're considering, and this is why it's so popular that not as many botnets are going to be attempting to actually exploit your APIs or your web applications, essentially representing the largest amount of risk of all of the member bots within this credential stuffing botnet. Lastly, now that we've covered brute force, active exploitation, another key indicator that we're tracking around the behavior of this credential stuffing attack is also password spraying. So iterating multiple passwords to try to access this WordPress website. Again, in the example that we mentioned before, if your web application doesn't use WordPress, this will be even more suspicious versus if WordPress was in use. Now that we've reviewed just a few behaviors that are being tracked within this credential stuffing botnet, let's start to dive into how the ThreatX platform is actually detecting these bots. So ThreatX uses a combination of techniques to detect a wide range of automated threats without introducing additional friction like CAPTCHA and other bot mechanisms that negatively impact customers' experience. A few examples of the techniques being used within the platform are first, active interrogation. This is where ThreatX challenges suspicious actors with interrogation to see if they react with tar-pitting traffic or returning web cookies to differentiate a legitimate user versus a bot. Also, ThreatX uses application profiling to automatically identify normal behavior by monitoring usage in underlying services to enable early detection of anomalous behavior. This is an example of how ThreatX detects and tracks threat activity. As we can see here, Hateful de la Plaza tried to attack the authentication endpoint for our specific API, all within 1 minute of each other. If we dive into Hateful de la Plaza's activity, we can start to see the metadata that we talked about previously around the user agent, the TLS fingerprint, full path parameters. Here we can see the authentication endpoint is the target, as well as the parameters being passed in. Note the user that's being passed in, and if we view other activities, what we'll start to see is these credentials beginning to rotate through. So in this case, the user changed to get, and if we keep scrolling down, we can see other examples of how this bot is cycling through those various credentials, attempting to gain access. Now, this is just one example of a bot that was detected very early on in its credential stuffing attack. Now, let's hop into a bot that's been automatically blocked with ThreatX's risk-based blocking to understand how the platform will stop attackers in their tracks before gaining access to accounts. Diving back into ThreatX's credential stuffing botnet, let's take a look at one of the bots that was automatically blocked with ThreatX's risk-based blocking. Here within ThreatX's threat entities table, we can start to view a timeline of this bot's specific activity and when he was actually blocked from within the system. There's also a few other request information that's going to be important to call out during this triage period, such as the path being targeted, the user agent that's being used, TLS fingerprint, and also the parameters that are being passed in. Taking a look at this bot's activity, there's a few key attributes that we can notice are starting to change. First is the rotation of user agent. Before July 12th at 1:30, we can see the user agent was focused on a Python request. And just over an hour later, at 2:30 p.m., we can see that user agent changed to a completely different value. Now, let's dive into this specific activity to learn more about what exactly happened during this blocking period. Now that we've expanded this, we can see the specific parameters that were passed in, as well as the rule that was detecting an exploitation attempt of injection, which caused ultimately this bot to go into ThreatX's blocking mode. ThreatX automates risk-based blocking if activity exceeds a specific risk score. This in turn helps the platform stop high-risk transactions instantly and also reduce the amount of manual tasks that security teams need to respond and stop threats. The next example that I'm going to walk through is a low and slow attack. This is where a bot might start reconnaissance earlier on in the attack and slowly advance to a more malicious attack method. Here, I'm going to open up Upset Minges, and we can dive into their activity over time. Here we can see Upset Minges was originally detected on July 7th. And some of the activity that they were performing was mostly reconnaissance with a few brute force examples. However, after 4 days, we can see that Upset Minges came back and now is attempting a DDoS attack on this specific application. Now that we've reviewed Upset Minges' activity over the past 4 days and how it's changed, what we can also see is specific information in that activity and how it's advanced over time. A specific callout that I'd recognize is the change in TLS fingerprint, changes in the user agent. So we can see at one point the user agent was a Chrome MacBook, but is now a Killnet. And also we can see the change in path parameters. And that really represents what's being targeted in this attack. An easier way to see what's being targeted is we can jump over to the endpoint statistics within this entity and see exactly what was being targeted. So here we can recognize that Upset Minges wasn't just targeting our API, but also other paths of our web application. The main target, however, is our authentication endpoint. The next place that we can jump into when trying to understand Upset Minges is also the responsive actions. This is also where we can start to see ThreatX's risk-based blocking starting to take place, where blocks were occurring on July 7th, and also the second block occurred on July 9th. Now, ThreatX tracks bot activity. So if this bot continues to come back 3 times, at the 3rd time, it'll be automatically added to our permanent block list. And that's really how ThreatX combats both the aggressive volumetric bots as well as the low and slow bots attempting to evade detection. Jumping back to ThreatX's credential stuffing botnet, it's important to emphasize that security teams are always trying to keep up with changing attack patterns, as this requires constant correlation from various sources to get a complete picture of what's happening. In this example, I'm going to walk through how your security team can add additional definitions to a botnet to account for how behaviors are advancing or changing over time. Taking a look at all of the members' various behavior, we can start to see the various types of rules being detected. As we reviewed, one of the key rules that are being tracked within this botnet is the 3 unique login. But also what we can start to see is other rules being triggered, such as the block login relay parameters. Let's dive in and investigate this rule's behavior a little bit more and see if this is something that we want to start to track and consolidate within our credential stuffing botnet. Jumping into all the attackers that are matching against the block login relay parameters rule, we can start to see that there's a high activity of threats that are starting to use this behavior. A number of them do identify as credential stuffing, but most of them are being tracked as potentially bad traffic. This could be a key example of how a botnet is advancing its behavior and how we can start to consolidate this view even more by adding this rule to the credential stuffing botnet. So jumping back to the botnet, it's very simple to actually add additional criteria. We can simply edit the botnet, and we can add this rule to the definition very easily from within the botnet dashboard. After looking up and now saving this rule to our botnet, we'll start to see other bots starting to be brought into our credential stuffing botnet that continue to match both behaviors now. With ThreatX's botnet console, security teams get visibility into how effective their current rules are detecting and blocking botnets, coupled with the ability to update rule criteria fast and easily, enabling teams to constantly improve the effectiveness of their bot protection.